Oh no, here we go. This is, what section are we in? 7-5, day 3. One example today. It's a challenging one.
One example, wow.
Yeah, isn't that good? One example today. Okay. We've got a plane that's flying 168 miles per hour.
Okay.
But the plane wants to fly on, well, that's two words, fly on a bearing of 57 degrees, 40 minutes. There is a south wind blowing at 27.1 miles per hour. Can you find the bearing the pilot should fly and the ground speed? So this is where a pilot or a computer would have to account for the wind. So she knows what direction she wants to fly in, 57 degrees, so if we call this, she wants to fly this way, but she's got to account for the wind. So if she points the plane about this way, hopefully the wind pushes her over there. So that's the kind of problem we're talking about. She's got to account for the wind and end up on this bearing. So we always have the 3 vectors going. We've got airspeed, wind speed, and ground speed. The wind is easy to pick up because it says wind. Here's our wind vector. This wanting to fly on this bearing. Which vector is that? That's where I want to end up on. That's the resultant, which we call the ground speed. What's this plane flying at 168 miles per hour?
That's the first one.
That's the airspeed. It's the engine speed. They're implying that there. So that's our airspeed vector. Okay. It says find the bearing the pilot should fly. So this bearing is on the airspeed vector. And then obviously ground speed. So we're looking for 2 things. The bearing of the airspeed vector, and we want to know how fast the plane is going. Okay. Normally, I always write the airspeed vector first. But the only thing they told me about the airspeed vector was the speed. I have no idea what direction to draw it in, so I can't possibly start with that one. Okay? So, it's usually I do airspeed plus wind equals ground speed. But you know these are commutative. I can go wind plus airspeed equals ground speed. So I'm going to start with the wind vector because I think I've got everything I need about the wind, right? South wind at 27 miles per hour. What does it mean for the weatherman to say a south wind?
It's going north.
The force is moving to the north. Force is going north. So we've got a north wind, well, blowing north wind. Here's the wind, 27.1. Well, I did, south to north. Because it was directly south, I could just draw directly north. Well, no, because there's no number there. South is down, north is up. So I kind of did. Just did it physically. Okay, wind is done. Wind. Where would the airspeed vector get attached to this if I'm going wind plus airspeed? At the arrowhead. But again, do I know what direction to draw that thing in? Clueless. I can't do it. I cannot draw that vector in right now. What else do I know about this problem? I know the resultant, what direction that's going in. So if the airspeed's getting attached here, where would the resultant start?
The dot.
At the tail. This is where the ground speed starts. So I'm going to draw that one in. So, let's see, what do we got? 57 degrees, 40 minutes. So I'm going to swing over. Here's the ground speed vector. $57.40. I have no idea how fast it is, so I'll just call it G. But now I've got an idea where that airspeed is at. Because the airspeed would have, the tail would start here and the arrowhead would finish down here. So I had to wait to do the airspeed on this one. I do know the airspeed is 168. So that was the challenge in this one, is we couldn't do the two vectors that we would normally add together first. I had to save one of them for the last part. Okay, well, it looks nice. They gave us 3 parts. Oh, we can't do it, or can't use a program, because what 3 parts are here? Angle, side, side. We didn't write the angle, side, side program, but do we know how to solve an angle, side, side? It is not a pain, because once we find one part, we're going to be able to grab a program. So, oh, what was it? Was this under the law of sines, or was this under the law of cosines? This is easy law of sines. So we're going to set up our proportions. 168 over sine of 57.40. Over sine of, we need a letter down there. Hey, let's put an A down there. So go ahead and tell me what angle A is. Do your cross multiplying, dividing, inverse sine. Once we've got angle A, we'll grab a program and solve the rest of the triangle. This is definitely more of an extra-ket style problem here. We have to do extra work by hand. What did you get for the angle? 7.8? Is that what you said? Sounds about right. It's small. 7.
It's 7 degrees 50 if you want to use degrees. Yeah, 7.
Now make sure everybody's got it.
What is it, 7.8 or 7?
Got it.
And I'm hearing 2 8s. Anybody else?
7.8.
7.8.
7.8.
7.8.
7 degrees 50.
Okay, if we're going 7.8.
I got one more.
What? You guys rounding along the way?
Wayne, you have to use the inverse sign.
Okay.
Are you sure?
Yeah, because you get 0.136.
Yeah.
Okay, I'm done.
Quinn, you want me to show you how to do it real quick? Okay, all right.
She's been on a rough day.
Rough day. Eat some more Nutella. All right. Okay, now you've got 2 angles and 2 sides. Pick any 3 parts you want that's not angle, side, side, and run another program. So use angle, angle, and you can choose either side. Okay, go ahead. Hey, we're not done. You guys might want to focus. Run angle, angle, side. That will give you the other angle here and the ground speed. So give me ground speed when you're done. What do you got? 182?
Yeah, I got 181.6.
181.6 is 182.
Do you get a different answer if you use a different program?
Yes. If you use the 168, everything's going to be just kind of close because of rounding this bugger.
So,
But this is good enough.
so like if you use angle side angle, never mind.
You can't use angle, side angle.
Figure that out.
Okay, good. All right, this angle over here, please. 115. I wouldn't know if it said 50 or 15. Okay. So we got the ground speed. There's one of our answers. We wanted the bearing of the airspeed vector. Bearing comes from, here's my airspeed vector. I want this angle. How do I get it?
180 minus 1.
180 minus 115. See how important a good picture is? Once I draw in what we're looking for, you guys have no problems doing it.
65.
So a 65-degree bearing. Okay. You've got 5 of these to try. They are not that easy.
Yeah, they are. You are so reassuring. Don't lie.
Do it.
If they're not easy, why do you give us so many?
There's 5 of them. Okay, there you go.
Way too many.
Yeah.
I have